Just before we begin, I just wanted to let everybody know that the speaker is going to actually present in French. So if you have your headsets, that would be great. So good afternoon, everyone, and welcome to this educational session. My name is Chris O'Connell, and I'm the registrar and the board member for the province of New Brunswick. And I'm going to be the moderator for today's session. As I said at the beginning, as a reminder, the presentation will be given in French. And so if you haven't already done so, please make sure and pick up a headset so you can get the translation. The following presentation will last approximately an hour, and our speaker has indicated that although we're supposed to wait to the end for questions, he would take some questions as he rolls through his material as well. So the name of the presentation is Quebec Study of Visibility Issues Affecting Drivers of Heavy Vehicles. And to discuss this topic with us today is Sébastien Bédard from the Trucking Safety Branch with the Ministère des Transports, de la Mobilité Durable et de l'Électrification des Transports du Québec. That must be really hard to get on a business card. Sébastien holds a bachelor and a master's degree in mechanical engineering from Laval University. He joined the Trucking and Safety Department of Quebec's Ministry of Transport, Sustainable Mobility, and Transport Electrification in 2009. He's in charge of a number of files and working groups on road vehicle load and dimension regulations, and he is also the lead on multiple studies aimed at improving road safety, including one on the visibility for drivers of heavy vehicles. So I'm going to turn it over to him now, and we'll have a question and answer session after.
Good afternoon. Thank you for being here. As I have said, we're not very many here in the room, so if you want to stop me during the presentation and ask questions, do not hesitate. And if you lose me, I'll try not to speak too quickly, so do tell me. Today I'll be speaking about proposed solution to improve pedestrian detection in urban areas by heavy vehicle drivers. So I will present to you the study at the department on heavy vehicle driver visibility. It is a study that led us to a solution that I'll be presenting to you. I'll talk about the methodology, our essays, the results. So it was initiated by the MTMDET, that's the name of our Department of Transport and Transport Electrification. The study was carried out in partnership with the SAAQ and the City of Montreal. The objective of the study was to reduce the risk of accidents caused by insufficient heavy vehicle driver visibility. So, of course, the study, the first step was to look at the problematic situations and analyze them. Step 2 was to assess available solutions
En anglais, puis, mais c'est des...
It's a bit mixed up here because I'm looking at the English slide but speaking into French. And so step 2 was to assess available solutions, and step 3 was to implement a better solution. So if I continue, the first step was to identify problematic situations. How did we do this? First, we did a review of the literature. We analyzed numerous coroner reports to look at the problematic situations linked to visibility. So it's really a matter of visibility that we were most concerned with. What did we look at in our literature review? Well, 6 problematic situations linked to driver visibility. So first cases, we talk about vulnerable users. We have two situations dealing with pedestrians. The first one is dealing with the pedestrian crossing in front of the vehicle. The vehicle didn't see the pedestrian and hits him or her. And in the second case, we have a pedestrian here crossing an intersection, and the truck turns right. So these are the first 2 cases linked to visibility that we acknowledged. To give you an idea of the blind spot in front of a truck, is just a photograph, but here this pedestrian is about 5'6". The driver, ordinary driver, is here. We don't see much. The pedestrian is not really very close to the vehicle. It could be really any pedestrian crossing an intersection in front of the truck. He does not believe he may not be seen. He has a blue toque, which makes him easier to see, but it is problematic, no doubt, just to give you an idea. Other 2 situations with vulnerable users. The first is with a cyclist. He's driving first, straight. Both are not turning right. The cyclist is going straight and the truck is turning right. And the second one is a truck going backwards on a pedestrian or an individual just standing there. More frequently, these situations are found in workplaces. It can be a construction site, and often there are other issues linked to these situations. But these 4 situations are linked to vulnerable users. There were 2 more that we looked at in the literature. Trucks, again, changing lane, going to the right lane. 2 different cases, because these are not the same zones around the truck. It's not the same visibility issue. It's not the same mirrors at stake. One is more, it's closer to the front part, and the other one is more towards the back of the truck. But these 2 situations are less likely to be involved in serious accidents or death. It's more a cause of damages, for example. So following that, we identified these 2 situations that we prioritized. So these are the 2 situations that we looked at as a priority. Why? Because they involve vulnerable users, but also because they are more frequent. Sometimes, indeed, the pedestrians are being hit by a truck going backwards or a cyclist, but we talk more about cyclists, but in fact, these 2 are the more frequent ones. And there were also a lot of reports by coroners that report on these 2 situations. That's why we made them a priority. Another interesting element when we look at situations is that we have similar situations, but that are statics at low speed. And we don't need to take into consideration the movement or the task of the driver as we would do for cyclists. In these situations, the driver, usually what happens is that the truck is stopped or it's going very slowly, and the driver decides to cross at an intersection. And the cases we have is that there was no way to know that there was a pedestrian there. So that's why we decided to make these 2 cases priority. So parenthesis on snow removal vehicles. Well, these studies were started a few years back, What happened is the situation in Montreal is in the span of 2 to 3 weeks, 4 pedestrians were hit by these trucks in situations in snow removal operations. And the snow removal part of these events they were pushing strongly for this to become an issue, but we didn't want this to be a snow removal problematic. It is rather an issue dealing with all heavy vehicles. So yes, indeed, a snow removal vehicle will have more blind spots. As you can see here, we can't see everything. Weather conditions also are more difficult, so it's a particular case, but there are very few accidents really linked to these conditions. Accidents, even when dealing with snow removal operations, are linked to blind spots or problems really common to all vehicles. So that's why I wanted to make this precision. We didn't want snow removal operations to take the whole part of the study. We wanted it to be more general. But with snow removal operations, there are some interesting and particular circumstances. It is snowing, most probably. That's often at night. So we wanted to look at that also and to see if the solutions would be efficient in these conditions. So step 1, we looked at the problems. We prioritized the urban pedestrians. Step 2, we are looking for solutions. Problematic blind spots in this sector. This is the most problematic zone. List of potential solutions. The first was to improve the visibility of the trucks, improve cabin truck visibility. It could be very efficient, of course, but to give you more context, I'm in the Ministry of Transportation in Québec. We're a provincial body. We do not manage building of vehicles. We do more what we could call retrofit on already existing vehicles. So for us to change the culture of trucking in North America was a bit utopic, really. To change the trucks for more European types of trucks. It was not a solution that was realistic for our work group, but these solutions could be looked at more long term. The other kind of solutions was to have more mirrors. Well, we could look at the European standards, school buses in Canada, and many other kinds of mirrors could be used to improve visibility. If I look at the European standards, well, we have to be careful. In Europe, trucks look like this here. So when we look at European standards for mirrors, they are adapted for trucks that already have a better visibility. It can be inspiring, but in North America, many things may not be applicable. Other possibilities for solutions to improve visibility or detection with camera monitor systems or detection technology systems. These are various potential solutions that we looked at. We had a working group. We decided to look at mirrors as a priority. Why? Because it's not costly, because it's an equipment that is easy to buy, it's available everywhere, it's easy to install, and also, regarding the driver, it is a piece of equipment that will be accepted by all drivers. All drivers know what a mirror is, what it will do, what it won't do. So we decided to privilege these solutions, mirrors. That means that we excluded technology and camera and detection systems. Why? Well, we made that decisions a few years back, but in most cases, it's still very much true today. The reliability of these systems has not been demonstrated, especially with regards to detecting pedestrian in an urban setting. There is no study that will say this system will be 100% efficient. So this is important. And it is also true today with most autonomous or semi-autonomous vehicles. So for us, this efficiency or this reliability that had not been demonstrated was one of the reasons why we didn't go in that direction. Another reason is driver acceptance. We are talking about a new technology. There's a lot of resistance to change in the trucking environment. What would be the impact of a technology on the driving tasks of false alarms? What we are expecting is that a system that would not be really fine-tuned, well, there would be a lot of problems. False alarms, for example, a system that would ring all the time, or with false positives, what will drivers do? They probably unplug them. So this is something that had not been looked at and was not really known, so we didn't go in that direction. And also, we expect that these systems will be more costly to buy and maintain. So we are looking for solutions that are applicable short-term and that can be applied on already existing vehicles, because often these companies have one or two vehicles, small entrepreneurs with a few trucks circulating in urban settings. So all these reasons explain why we didn't look at all these advanced technology systems. But if we can't find solutions with mirrors, if it is not sufficiently effective, we'll have to look at other solutions. So we prioritized the mirrors, and we looked at the best combination of mirrors, and we wanted to know if it was possible to eliminate blind spots around heavy vehicles. So we started a project with the École Polytechnique in Montreal on road safety to compare rigorously different solutions of mirrors. So I emphasize this: the efficiency detection of a pedestrian is not necessarily that I see him or her in the mirror. There's the idea of detection that we wanted to enhance. That means we want the driver to be aware of something. We wanted to make sure that this notion be taken into consideration. So we asked Polytechnique to develop a few projects. First, to have a testing protocol to make sure our tests would be rigorous, reliable, and reproducible. And after that, we drew up a plan. There are various heavy vehicles, tall, low, long, longer. So we made certain choices in terms of certain types of trucks and certain types of mirrors. And then we conduct tests in controlled situations. All mirrors on a single vehicle. And also we tested them on various environmental conditions with rain and dust, etc. So these are the results of these tests. First, we defined our pedestrian. We decided the pedestrian would be a 6-year-old child. That's about 45-inch tall, and we said that in order to detect the child in a mirror, we have to see the cylinder entirely. That's the criterion that we used, because in the mirror sometimes we don't see very much. Maybe some may ask, why did you take a cylinder? Why orange? Well, our objective was to compare mirrors amongst themselves, to look at the best solution. It's not necessarily to say we wanted to see if a pedestrian dressed in black would be easy to see. That we wanted to compare mirror to mirror. We had a testing site in a warehouse in Montreal. We have squares drawn on the ground, and we could say where the cylinder was visible, partly visible, and not visible. So it was inside, so we were not subjective to weather conditions. We could light up the lights or shut them off. The trucks was this one here, International 7600. We decided it would be the most representative of the worst cases. First phase of testing, we tested 16 mirrors separated into 5 categories. First categories were school bus mirrors. There are standardized in the 1100 standard, and other types of mirrors to see up front. Some are not standardized. It's another category that we had. The third category, convex mirror on each fender. On the fender, often trucks will have a convex mirror. This mirror does not see up front, but it will cover the zone to the right of the cabin. And this mirror could be combined to other vehicles will have, for example, mirrors to see up front. Front with a front view, so we wanted to quantify the results with these various mirrors. And the fifth category, it's called mirror above passenger side door, and it allows the driver to see the ground. Often these mirrors, you'll see that on current vehicles. You have to understand that most entrepreneurs or truck owners, their objective is to work better. So they will use mirrors like this one to align their vehicles on a construction site, or this one here to see up in the front view. But it's not to improve detection of users or pedestrians around them. It's to work better. So we wanted to know how this could be quantified for pedestrians. And of course, won't hide anything from you, but it's really these two types of mirrors that were the best solutions to improve visibility around the cabin. So a few examples of the results. And I will explain first this graph. You can see here in green, this is the direct visibility zone. The driver sees the ground. Here is the partial visibility zone. The driver sees partly the yellow-orange cylinder, and at the bottom, it's total blind spots. Driver does not see the cylinder. And in blue, these are the mirrors, the round mirrors under the flat mirrors on each side of the truck that will allow the driver to see the zone in blue. So that's my truck. It respects all Canadian standards. As you can see, we don't see very much around the truck. Here is a truck, a combination of the mirrors adjusted for school buses. When we adjust the mirrors for school buses, this is the gain in visibility that we have. We see that front view is highly improved, but the surprise here, we thought really that it would be a solution, a complete solution, but there's a big hole here. And the reason for that is quite simple. The mirrors are adjusted in a symmetrical manner on each side of the truck, and it draws somewhat of a line, but there remains a hole here when we adjust the mirrors according to the school bus standard. For school buses, it's not problematic because trucks, the buses rather, have a door with a glass on that side. So they don't have a problem of visibility on that side. But for a truck, it could be problematic because here, for example, let's imagine we are at an intersection, a pedestrian there. If it's a truck with these mirrors, well, he could not see the pedestrian. The second type of mirrors, not standardized, what is interesting here is that we could not adjust them according to the school bus method because it wasn't meant so. And the adjustment methods didn't work. So the researchers of Polytechnic looked for a new method, a new way to adjust the mirrors, and they put them a bit more to the right. So it's a tandem method, we could call them, and adjusted to the right of the two front mirrors and they managed to modify the blind spot, but we lose a big part on the left. But a blind spot to the left for a heavy vehicle is not so problematic compared to a blind spot on the right. So that is what we saw with the second method, with the other mirrors. So what do we draw from all this? Well, the best solution is to add add mirrors for the front, but they must be adjusted. It is very important. That's the first observation that we made after making our tests on control sites. Second phase of testing, we wanted to look at other ways to adjust the mirrors. We call this the hybrid adjustment. So to the left, we would remain with the school bus system, and the right one, we would adjust it differently. So we would keep a certain visibility on the left, but the right mirror will cover entirely the right side. So we tested it. We changed the vehicle for various reasons. That's the City of Montreal vehicle that we used. Just to show you, that's the school bus here, mirror, and that's another mirror that we added. So back to my drawing, the City of Montreal vehicle is a bit shorter, and the blind spots are smaller, but they are there just the same. So if that's my right mirror, adjusted according to the new method. It will allow us to cover this whole zone, and when I add this, I add my left mirror, adding room at the front, and now with the two of them we cover the whole problematic zone. So that's what we found very interesting. So very quickly on this other part regarding environmental conditions, we wanted to test this at night during rain conditions and during winter conditions. Of course, if we have snow on the mirror, it won't be of much help. But what we did is that we used dirt. We tested dirty mirrors to make it look like a winter condition. So this is the result. I'll show you the photographs. You'll see that would be a night scenario with no other combination. We see the cylinder quite well. You might say it is orange, but still the mirrors will help us see it quite well. That's that's day condition when it is raining. We do see the cylinder, even if we lose part of its precision, so it works night and day. But when it's night plus water, nothing much to do. That's where the notion of detection is more at stake. If we look well, we see there's something orange, but it's very hard to detect a cylinder as such. That's another mirror here that was not in the study, but that will help us compare. We do not see very well. So this would be messy conditions during day conditions, not much of a difference. Messy conditions at night, that's a bit like the rain. We can't really distinguish much. Conclusion of our tests.
The best solution would be to improve the conditions with two mirrors adjusted in the hybrid method. These two elements go together. It is not only to adjust mirrors, but we have to use both. We saw that there were a few limitations associated to mirror adjustments. It's the difficult environmental conditions. However, we can have heated mirrors, but overall, there are still limitations. And my conclusion is that it will be difficult to do any better with mirrors, of course. And if we are really looking to improve visibility and detection, we'll have to go towards technological solutions in these conditions. But here, what we see with technology solutions, they will not be better in rain or snow conditions. There's still this issue. In summary, to show you the picture here of all three different configurations. The first one, which is standard right now, no front mirrors, the school bus adjustments with a few gaps here, and the hybrid solution that we are proposing. Once it is done, I don't know. Do you have any questions at this point? We talk about responsibility for the driver, but what about the pedestrian? Well, yes, that's not the purpose of my study. Yes, this is something that we recommended from the very beginning, even before doing this test, and SAAQ did a lot for pedestrian awareness. They have a team visiting the province, but awareness is a lot of efforts, Results are very difficult to quantify, but yes, indeed, you're right. I can even go back to the first slides. The first thing we did with this study, even before testing mirrors, we presented a few recommendations. One was to make pedestrians aware, educating pedestrians, and also education of drivers. Just questioning, is there anything we can do with drivers? The other recommendation was more with about infrastructures, pedestrian crossings, and so on. Our objective was to look at the vehicle. What could be done to improve visibility on the vehicle? But it's a very general issue that we can address in many ways. Concerning testing, did you use a virtual system for mirrors or? No, we did not. We had a warehouse, one truck, and we installed everything on the same truck. We took pictures, a lot of pictures, and we judged in controlled situation. Next part are actual conditions. This is where I'm going to show you what we did next. But we didn't have a simulator or virtual reality. I'm from the Teamsters Ministry of Transport. Will he put that, implement this? I'll talk about that at the end.
And from your presentation, you mentioned about the cyclist and the pedestrian. So have you looked at any data, accident data, and with the truck and the motorcycle? Or have you thought about in the future you're going to do some kind of study with the motorcycle?
We prioritized the pedestrian from the start. So we did not look further for the cyclists or motorcyclists, or we concentrate or research about for the pedestrian in the urban area. But if we solve this problem, it will solve a part of other problem also. Is it clear or?
Different from the pedestrian and motorcycle or even scooter in Quebec City and Montreal, quite a bit of scooter on the street, and is the speed.
Okay, but no, I don't have data about that. I never saw, in fact, an accident between a scooter or a motorcycle and a truck. Or if there is, it's not related to visibility, or that answer, it's okay. Okay. Oui.
OK. Au niveau des miroirs, est-ce qu'il y a quelqu'un qui a pris le temps de se positionner comme camion entre un chauffeur et d'évaluer?
Was the driver in the truck and able to analyze Sometimes the headlights mirror are in the mirror, and the yes, I'll say a few words about this. I'll continue if I may, because I'll try to. Now, the next phase, as I said, was to make an actual trial in the field, because we tested the mirrors on 1 or 2 trucks, and we wanted to see in the field on the road. So we had 4 objectives. The first one was to check the feasibility. Would it be possible to install these mirrors on all type of vehicles? Any mirrors, will it be possible to install them on the trucks? Secondly, what about the efficiency? Will it be efficient in any other configurations? If it's good in the warehouse, will it be efficient elsewhere? And thirdly, the acceptability by drivers. I'll tell you about the problems, but will drivers accept a solution and use a solution? And that's super important. Any change we want to bring, if we don't have driver's acceptability, they will remove it anyway. Even here, it's about mirrors, but it was any technology system. We need to have compliance by drivers. Fourth objective was to have a best practice guide to determine the content of what would be that guide. Sébastien, most trucks, manufacturers, they have that mirror system as an option, where the cost of the option is at stake here. If they add those options, some employers don't use that. Same for school buses. It comes with the mirrors in the front. And some models, it's automatic, it's already installed, so. And drivers ask for these front mirrors. But very often it's a question of cost. Yes, but it's not that expensive. Mirrors are not that expensive. The idea, as far as we're concerned, well, costly. I mean, it's possible to have all this below $1,000 on a $185,000 truck. Yeah, does it answer this? I don't have any other answer. So our fourth objective, as I said, was to develop a guide. Currently, what we want to do is to have a voluntary implementation of this solution. We don't want to have any regulation. Now, to develop a guide, we have to know who is it for, what kind of mirrors buy, how to install. So many questions we have to ask. We used also actual conditions testing to get all the information. Now, I'll give you an overview of what came out of the actual trials. And yes, other objectives. We want to have a general installation method that will be able to be used for any type of vehicle. We also wanted to have a simplified method for measuring effectiveness and fields of visibility. Someone who would be able to say, does it work? It doesn't work. We want to test on a full year, like summer, fall, winter conditions. Just to give you an overview of the scope, 4 combinations of front mirrors were tested on 16 vehicles, 8 from the ministry and 8 from the city of Montreal. In Montreal, the vehicles are all the same, so it is possible to compare mirror combinations, and ministry's combinations are all different. So that was a way to see if the developed methods of installations will be useful for all. We also got the driver's feedback through a questionnaire. Here is where the mirrors will be positioned. The height here, the windshield here, a bit in front, 5-6 inches in front of the hood here. And the further you are, the better you will be able to see. But drivers and people will find it a nuisance. So if they are too close to the truck, you'll see only the front of the truck, and they will not be useful. On the side of the truck, same thing. So this is a position that was proposed, not to go too far beyond. The hybrid method I talked about, remember, the school bus misses are the one on the left side here when you're in the vehicle. The mirror is around the corner, 45 degrees, the corner of the vehicle, but on the right here, we propose to adjust it at 90 degrees, just to tweak it to the right to cover the problematic zone. So when we mounted the installation brackets, we have to put the mirror on in that type of angle. We met a few problems, like the question was asked earlier on. Of course, some mirrors are not made to be adjusted or tweaked. That's really sad, but it does exist. So we had a hard time adjusting some mirrors. And also there were interference with a snow removal equipment. It's big here in front. And what we were allowed to do, though, we were able to move the mirror and see if it would be still efficient or not once it is moved. So this is what we did. Even if we moved a bit the mirror compared to the method proposed, it would work anyway, except that a snow removal vehicle, it can be a problem. But in the winter, snow removal truck, I mean, these are not the trucks with blind spot issues, because the pedestrian will not be on the right because of the equipment. So this mirror can be removed when the equipments are on in the winter. Back to the previous question that was asked, some drivers complained because they were not at discomfort because of the glare, and I tried to put pictures, not easy, but the solution proposed was to have a deflector here on top. The discomfort was due to a second set of headlights. Here you can see there's a major difference. There's a major difference. Not many drivers talk about that, honestly. No, really very few of them talk about the glare problem on the whole group. But we still found a solution, because it can happen. Finally, yes, it was possible to install all mirror combination on all types of hoods. I show you pictures here, all trucks that are different, and you see how it... So the positioning method is valid. It was tested in many situations, always worked. The other objective was to see if mirrors were efficient. Now, to do that, it's RV7, the cones here in Quebec, like the cylinder we had in previous pictures, and to have a grid around the problematic area. And quantify, now will we see easily cylinders in the mirror, or we may bring them closer. So each truck went through the test results. Well, very impressive. In all cases, they had the exactly same results. All the cylinders, all squares 50 centimeters, so we see at 2.5 meters on the side of the truck and 1.5 meters or 2 meters in front. All cylinders were visible in the mirror, except mirror number 10, because it was partially visible. We knew that from the beginning because we took the right mirror and we adjusted towards the right. So this is the one in the school bus method that covers that zone. For us, it was very clear that the right zone is more of an issue for vulnerable users than the front and the left, because front left, the driver sees people coming before. It is not a blind spot. It's just that the visibility is less good. Otherwise, the problematic zones where there are accidents, all that zone is very visible. We did that verification with different adjustments on the seat, driver's seat, and and position, and also according to different errors in the positioning of the mirror, it worked anyway. The third objective was to have the driver's acceptance. Now, this was more difficult. Why? Well, it's difficult to have meaningful feedback from drivers for many, many reasons. First, well, there were many delays in the project. Drivers changed, and on some vehicles, mechanics removed mirrors to replace them by front mirrors. And imagine that you're driving a vehicle with snow removal equipment on the side, and you rely on your side mirror to see where your equipment will hit the ground, and then it is replaced by a school bus mirror. Well, the image will not be the same. You will not be able to work this. Well, that was not the goal. The goal was to add a tool to detect vulnerable users, not to change the work environment. Some drivers didn't appreciate the solution for some of these reasons. Drivers also changed along the way. It was difficult to have a constant follow-up over the whole year. Still, results were very interesting. In the questionnaires, nearly all drivers said that the solution was useful and effective, especially at low speed in urban environment. Those driving in the city with these vehicles appreciated because it made their driving easier, improved visibility, and that was the goal. However, as I said, we see the difference between drivers on the highway and those working in the city. They would use some mirrors were removed because they thought that the image was too distorted, and also it was difficult to judge distance, as I explained. There's a context related to that, and this is where we have to see who this solutions is targeted towards. There are some issues still. Other findings: environmental conditions we saw in the warehouse with the test, but it is difficult with mirrors. And we have to be careful while these are installed. Mirrors can have to be readjusted because of vibration and so on. Some equipment on the front of the truck can have a conflict with front mirrors. So we want to put that in the guide and explain the various limitations. Now, what about the guide? To summarize what will be in the guide, we need standardized mirrors. Why? Because some are adjustable. This is designed to be adjusted on bicycles. We know that it's a technical standard, but these mirrors ensure that it will work constantly. The position of the mirrors are variations. It simplifies. It's not necessary to be so specific for a specific centimeter. No, to be efficient, as I said. Some vibrations. We recommend to use 3 or 4 struts to limit the impact of vibrations. And also to use self-locking nuts to minimize loosening. And as I said, it is less efficient or less useful on highways. It's a solution that was developed mainly for urban environment. If ever trucks have mirrors that they use for work, we have to keep those mirrors. Otherwise, it's a part of their tools they use. In conclusion, 3 objectives we have: is it feasible, efficient, and accepted? In conclusion, yes, it is feasible. Yes, it is effective. As far as acceptance is concerned, it is accepted in urban environment. Drivers do accept it very well in an environment, in an urban environment. The working group says that despite limitations and many factors, this is a less costly short-term solution to improve pedestrian detection in urban environment. It's not high technology. It's about mirrors, but this is our conclusion. Adding standardized front mirrors, adjusting mirrors according to the hybrid method, that would be the best solution to improve safety of pedestrians. We want to implement mirrors on a voluntary basis. Given the limitations and also given the fact that we don't want to be an obstacle to technological development, maybe that would not be as easy. With a best practice guide. What are the next steps? We want to write the guide, and currently it is in collaboration with the SAAQ. And then we want to distribute the guide to owners of heavy vehicles operating in urban environments, and we need to follow up and be aware of the various technology solutions Transport Canada has, because there are still limitations. And as we said, we focused on pedestrians, but we are looking towards cyclists, and we need a more technology solutions for cyclists. Any questions? Your target are vehicle buyers, companies who use those vehicles. But if you make recommendations to install mirrors, and once it's installed, since it's a safety feature, it should not be possible to remove it. Like companies who have like steel cap boots, well, this is the debate. Should it be legislated? What kind of approach should it be? And we thought, well, let's develop a guide and have a voluntary basis implementation. In any case, even if it is regulated, we need a guide. And the decision is taken at a higher level than our group. But we focus on a voluntary basis. And there are different ways of implementing it. It can be a simple guide like the one we have, or at the other end, it is a regulation, but there's something in between. You know, many things can be done. You have to understand that I lost my thought. Well, I'll think about it. Along the same line, it's not trailers, it's just well, that's one limitation. The person going to California, coming back, is not driving an urban environment very much. And going on a voluntary basis, well, it can avoid having this debate for this type of vehicle. I mean, barely never in urban environment. You have to target your end user in the context of harmonization. I think if you have a voluntary implementation, those targeted are the vehicles who are driving in urban environment. You know, the trailers, yes, well, trailers. this is the first step anyway. And this is our target. Yes, a tractor trailer, it's all the same cabin anyway. Wow. Yes, but it will work the same. We tested with big front trucks, and the goal of the project is to be sure that it will work anyway in all type of cabin or hood.
When you did the analysis of the first few accidents you had, did you study the mirror placement in the trucks that actually hit the pedestrians to see how badly off your recommendation they were, or even if they were properly adjusted?
If the mirror hit the pedestrian?
No, if the mirror in the truck was adjusted so that the driver could see reasonably well or not at all, or was the mirror pointing up in the sky?
Okay. No, we didn't study if the mirror is not adjusted, but it's between the school bus and what we propose. En fait, c'est mon idée que j'avais tantôt.
Oh, yeah, that's the thought I had before. If we had a regulation, let's say, what are we obliging people to have? To have mirrors? And if you need to have, there's no control on the adjustment. I mean, people just put up mirror and there, I comply. Or are you obliged for a result? If you look at European standards, they target truck manufacturers, and they have to set a result. In the province here, we cannot deal with manufacturers. No, we cannot oblige a result. We have to oblige a means, and it is difficult to force for a method of adjustment. We can do it, but how is it controlled? It's not easy. This is why the guide on a voluntary basis, as far as we're concerned, that was the best approach for the time being. I offer here, it's the best method for the time being. Why for the time? Well, we didn't recommend legislation. I always say for the time being, because if ever we see that voluntary implementation has no impact, nobody does it, and it is still, with all the technological solutions in the next year, if it's still the most efficient one and nobody uses it because it's voluntary, it doesn't, but I cannot say, we prefer for the time being, yes. For today, if I have something to recommend, it's a voluntary implementation. Can I have the picture with the final installation? How far is it in front of the hood? Well, we propose to have the installation point, it's 5 inches or in front of the hood. This is what we propose. Yes, indeed. If you can go up to 20, I don't know. With your test users. In some places, it's so tight, we need those extra inches. It's a voluntary implementation. For 16 inches, I don't know. I can make a big difference there. These are things we know. But currently, there is no solution right now. Maybe technology systems, or maybe camera. But there are other questions about drivers' behaviors, the impact that this is why we didn't want to go along that line. We want to have a very rapid solution.
We could look at that more, but I know that in 30 years from now there will be technological solutions to solve this, but even before that. But for the time being, And that is also why the implementation is proposed on a volunteer basis. We are conscious that there are limitations. Yes, very much so, I understand. My question would be to know if we could, perhaps if we could change the regulation, because right now a cyclist or a pedestrian has priority. Could we not sensitize these persons that if a vehicle is coming up, they should wait? Well, that's an entirely different scene, because awareness is something we work a lot on, but it's another thing. If we look at last winter's accident in the city of Montreal, a person died because she was run over. But if that person had waited, I understand. But in all the cases of accident, we can say it is the fault of the pedestrian, but it's not a reason to be run over by a truck. So all these principles are there to give everybody the right to have to right for error. But in all the cases of accidents that I looked at, the driver had no means to know that there was someone around his truck. It's not a matter of priority. Yes, officially, the person did not give right-of-way to the pedestrian, but he did not see him. So what we're looking at is to find solutions. We're looking for solutions for the driver to have more means to see around his truck. Because in most cases that I have looked at, and if the driver had that, he would not have run over a pedestrian. That's the main thing. So we could have made a very global presentation on safety issues and look at all of them, but it's a very specific case, and we propose something very specific. It's not perfect, but I think that in many cases it would help a lot. That's basically what we want to say. Thank you.
So thank you for your participation. I could tell from the comments and the questions that you obviously found the session very interesting. If you've downloaded the annual meeting app, we invite you to provide your feedback directly in the app, and you can do so by clicking on the program description that's in the app. We are also videotaping the educational sessions, and they're going to be available after the annual meeting for viewing on CCMTA's YouTube channel, and you'll be getting an email with a link once the videos are available. So we're going to be breaking now for a break with our exhibitors for another 30 minutes, and there's another session to follow at 4 o'clock. And just before we leave, I would like to, de la part de CCATM, j'aimerais te remercier pour votre...
On behalf of CCMTA, with this little token of appreciation that we'd like to give to you. Thank you.
Non, c'est correct.